Assalamualaikum warahmatullahi wabarakatuh. My name is Farhan Najmi bin Kamarudin with metric number AN2000034. Today I will present to you my PSM1 project. I am from FTK BNF. My project is SWIFTLET Century Surveillance, integrating temperature, humidity, and light sensor for enhanced metering. I am the student Farhan Najmi bin Kamarudin, and my supervisor is Encik Azli bin Roslan. So this is the content. There is a introduction, PSM1 Gantt chart, flowchart, problem statement, objective, scope of study, expected result, literature review, methodology, expected result of the simulation, PSM2 planning, conclusion, and reference. This is my Gantt chart. There is some thing that I planned, but the actual little bit run. So this is my PSM1 flowchart. We can start. Okay, this is my problem statement. The problem statement is SWIFTLET house are traditionally monitored manually, which takes time. Environmental condition assessment is necessary on a regular basis and can be difficult, particularly for large-scale SWIFTLET farms. Additionally, when environmental conditions differ from the ideal range, the manual monitoring strategy might not properly warn users, which could have a negative impact on SWIFTLET numbers. An automated monitoring system for an SWIFTLET house home utilizing the ESP8266 microcontroller, DHT11 humidity and temperature sensors, and LDR light sensors is suggested in order to overcome these difficulties. The technology intends to gather information about the SWIFTLET houses, temperature, humidity, and light levels in real time and send notification via a digital platform. So the objective for the project is to develop a monitoring system that allow farmers to monitor the SWIFTLET house, to collect data on the temperature, humidity, and light levels inside the SWIFTLET house from monitoring system, to setting up adjustable temperature, humidity, and light threshold alerts and notification within the mobile application. So the scopes for this project is, in order to direct this project towards its goal, 3 scopes has been established. The following is a summary of the scope. A farmer will be able to access the monitoring system from any devices with an internet connection because it will be a web-based application. B, the SWIFTLET house's interior temperature, humidity, and light levels will all be regularly monitored by the system. C, an alarm or notification will be delivered on the farmer's mobile device when the temperature, humidity, or light levels surpass a predetermined threshold. So what we expect from this project, by keeping an eye on the temperature, humidity, and light levels, the SWIFTLET house monitoring initiative seeks to provide a comfortable habitat for SWIFTLETs. An ESP8266 microcontroller, DHT11 temperature and humidity sensors, as well as LDR and light sensors, will all be utilized in the project. Provide application will be used to display the sensor on the mobile application. Whether the sensors reading are too high or too low, the application will also include features to switch on red or and green LEDs and a siren. We will have a better understanding on how to design a monitoring system for SWIFTLET homes and how to utilize various sensors to monitor environmental parameters at the project conclusion. So for the literature review, by keeping track of the temperature, humidity, and light levels, the SWIFTLET house monitoring project attempts to provide a comfortable habitat for SWIFTLETs. We will examine the many sensors used in the project and how they function in the literature review. We will pay particular attention to the DHT11 humidity and temperature sensors and how it may be used to track the local temperature and humidity. We also look at the LDR sensor, which gauges the amount of light in a certain space. We will obtain a better gap so how to combine the DHT11 and LDR sensor with the ESP8266 microcontroller to build a monitoring system for SWIFTLET house by examining a number of research. So for the previous project, I searched 7 previous projects. So for the first previous project, the Internet of Things for Indoor Environment Monitoring of SWIFTLET House. This is the picture of the project. IoT IoT is for the measuring environmental parameter. Is the second one, the snapshot of the cloud database. An Internet of Things IoT system was created to monitor and maintain the ideal environmental condition in SWIFTLET house, specifically for the growth of SWIFTLET based nest that can be consumed. Multiple metrics, including relative humidity, air surfaces temperature, were remotely sensed and remotely monitored by the system. So the previous project, the second one, automatic system of sound and light intensity for SWIFTLET house. So the first picture is the series automatic sound and light intensity tools. The second picture is the block diagram of the automatic sound and light intensity tools. This is the sound system flowchart for the first one, and the second one is the light intensity system flowchart. So for the explanation, an Internet of Things system was created to monitor and maintain the ideal environmental SWIFTLET house, specifically for the growth of the SWIFTLET bird nest that can be consumed. Multiple metrics, including relative humidity, air, and surface temperature, were remotely sensed and remotely monitored by the system. So the third previous project is environmental parameters in successful edible bird nest SWIFTLET housed in Terengganu. The first picture is a EBN SWIFTLET sampling sites, and the second one is data for environmental factors from rural area, coastal area, and urban area. So for compare environmental factors in coastal, rural, and urban areas for SWIFTLET house in Terengganu, Malaysia. Data was collected from 30 hours within 10 in each area. Temperature, humidity, light intensity, and sound levels were measured using specific tool. Results show that rural area had the highest temperature, followed by rural urban area and the coastal area. Urban areas values had the highest humidity, while rural and coastal areas had slightly lower values of humidity. Urban areas also had the highest light intensity, followed by coastal area and rural area. For the fourth previous project, design of controlling and monitoring system for room temperature, lighting, power, and energy using Internet of Things. So the first one is a block diagram of the system, wiring, and the second one is wiring diagram of the system. The third picture is the flowchart of the system. This study created a system to monitor and control room parameters using IoT. The system measures temperature, light, voltage, current, power, and energy. It uses sensors, a controller, and a Blink app for remote monitoring. The system automatically adjusts the light and fan based on sensors reading. Data is sent to the Blink app for display. The Arduino IDE software is used to control the system. Overall, the study developed a simple and convenient way to monitor and control room condition using IoT technology. So the fifth project is an Internet of Things Blink framework for smart home. The first picture is a design diagram of the project. The second one, prototype smart home system. This study developed a smartphone controlled home automated system using IoT, Raspberry Pi, Node MCU, and a Blink framework. The system allows for remote control and monitoring for electric device and include automatic functionality when the home owner is away. It uses sensors, actuator, and Node MCU connected to Raspberry Pi as server. The Blink app on the smartphone enables homeowners to manage and monitor their home's status for anywhere in the internet connection. So for the sixth project is an industrial process monitoring system using ESP32. So the first one, show that the purpose of the module system setup, show master module, and shows interconnection of sensors to the ESP module. The study focused on implementing on Internet of Things application for industrial monitoring. The system collect data from various sensors such as smoke, gas, fire, humidity, and control message wirelessly using ESP32 Wi-Fi module. The collected data is sent to the internet and can be monitored through mobile application cloud-based platform. So for the seventh project, a study of suitable habitat for SWIFTLET farming. There are 4 pictures that I get. The first one is the SWIFTLET farmhouse located in Asajaya, Sarawak. The second one is air temperature, relative humidity, and the last one is light intensity. The study focuses on implementing an Internet of Things application for industrial process monitoring. The system collects data from various sensors such as smoke, gas, fire, humidity, and control machine wirelessly using ESP32 Wi-Fi module. The collected data is sent to the internet and can be monitored to mobile application or cloud platform. The SPA32 module offers efficient data transfer, while cloud-based platform like Science and Blank provide easy access and control of the monitor parameter. So this is the table comparison. There are advantages, disadvantages, hardware use, software use, technology use, and the comments. So for the first one, the advantage is real-time monitoring, remote access, control, improved accuracy and efficiency, data storage and analysis. The second one, disadvantage, initial setup and cost technical expertise, maintenance, reliance, internet connectivity. The hardware use is SP8286, AM2302, digital humidity temperature, DH2 sensor, PMOS D1 MCU, and the software use is MQTT control protocol and cloud storage. Technology use is Internet of Things, and the comments by automating monitoring and giving real-time access to available data, the IoT system improve SWIFTLET farming. So the second one, also the advantages, disadvantages, hardware, software, technology, and comment. Same as third one, fourth one, fifth, sixth, and seven, which there is no enough time that I can explain all of it. So for the applicable literature review idea, indoor environment monitoring of SWIFTLET farm. An IT system was developed to monitor the environmental condition in SWIFTLET house for cultivating edible SWIFTLET bird nest. The system automate the sensing the and remote monitoring of parameters like humidity, air temperature, and surface temperature. Farmers no longer need to manually measure this parameter using handheld instrument. The system collects and stores data in the cloud, enabling the real-time monitoring to web interface. So for ESP8266, is developed by a special system. It's a versatile devices that include CPU, RAM, Wi-Fi connectivity, and operating system. It is commonly used in IoT project due to ability to host application or handle Wi-Fi networking function for other processes. For SWIFTLET home monitoring, the ESP8266 can be connected to humidity, light, and temperature system. The WA connect to the ESP8266 and displays sensor information. For the DHT temperatures and humidity temperature and humidity are measured using THT11 temperature sensor. DHT11 is a basic and ultra low cost digital temperature and humidity sensor. It measures the surrounding air and gives a calibrated digital signal output of the temperature and relative humidity. The DHT11 is employed in the SWIFTLET house monitoring project, which make use of an ESP8266 microprocessor equipped with humidity, light, and temperature sensor. So for the last one, is the LDR module light intensity sensor. The LDR module is a light sensor used in SWIFTLET house monitoring project along with the ESP8266 microprocessor. It measures the light intensity and sends this data to the Blink via the ESP8266. So the Blink application toolkit is a Blink is a user-friendly mobile app toolkit for IoT projects. The IoT platform Blink allows user for iOS or Android smartphone to remotely operate devices like the Arduino, Raspberry Pi, and Node MCU. In SWIFTLET house monitoring, with the ESP and sensor, Blink is used to display sensor value. So for the conclusion of literature review, the literature review of previous project highlight the wide-ranging application and advantages of IoT technology. This project demonstrates how IoT can monitor and regulate environmental factors, automate system, and improve productivity by using IoT platform, devices, and sensors, and real-time data collection and remote monitoring become possible, leading to increased efficiency and informed decision making. The project also emphasized the importance of environmental factors in a specific context such as SWIFTLET farming and smart homes. So for the methodology of this study focuses on creating a mobile monitoring system for SWIFTLET house, ensuring optimal humidity, temperature, and light levels. It involves analyzing existing literature, system design, and hardware components. The study adopts a mobile monitoring strategy that consider with SWIFTLET habitat using sensor to measure real-time environmental data. So for the 3D design, the first one is 3D view of the design. The second one is a front view of the designs. The third one, side view of the design, and the last one, top view of the design. This 3D contain of some pipe and some bekas for the hardware. So this is the flowchart of the system. So the system start and the process initialize system, and then the ESP connect to the Wi-Fi. If connect, it process to read sensors, temperature, humidity, light, and then show reading to blink. And then after show reading to blink, it continue by reading temperature if by the range. If the range is more than 36 degree and 29 degree, the red LED turn on and the buzzer turn on. If no, the green LED turn on and buzzer not turn on. Okay, it continue. If the humidity is less than 80% and more than 90%, the LED will turn on and buzzer turn on. And the last one, it will write the light reading, which is 5 lux. If it's less than 5 lux, then it will be okay. And if it's more than that, the LED turn on, buzzer turn on, and then the process will be repeated at the read sensors. So for the block diagram, this is block diagram. First of all, it have the battery to power supply the ESP8266, and then we have 3 temperature sensors, humidity sensors, light sensors, and then the ESP8266 will connect to the Blink app through Wi-Fi, and then the Blink app will have the data buzzer, LED, and the LCD screen. So this is the hardware used. ESP8266, DHT11, LDR, breadboard, jumper wire, feed male to male, resistor, 9 volt battery, and battery shield. The software used is Microsoft Office, Arduino software, IDE, Proteus, Tinkercad, and Blink. This is my circuit diagram. It used comping to ganti the Blink app. And for the simulation, there is some sort of problem with the simulation that I cannot be done within the PSM1. So for the expected result after the simulation, I expect that the project can be done within the PSM2 and the PSM planning. And the conclusion, by keeping an eye on the temperature, humidity, and light levels, the SWIFTLET House Monitoring Initiative seeks to provide a comfortable habitat for SWIFTLET. An ESP8266 microcontroller, DHT11 temperature and humidity sensors, as well as LDR and light sensors will all be utilized in the project. Phone application will be used to display the sensor data on the mobile application. When the sensor reading are too high or too low, the application will also include features to switch on a red and green LED and the siren. We will have a better understanding on how to design a monitoring system for SWIFTLET homes and how to utilize various sensors to monitor environmental parameters and the project conclusion. This is my reference. Okay, that's all from me. Thank you.